In my second curve sketching video, I'm going to look at cubic equations. Now the simplest cubic is y equals x cubed, and the shape is basically like this. When you cube a positive number, you get a positive. When you cube a negative, you get a negative. So unlike a parabola that keeps going up, the cubic goes up on the right side and down on the left. Now, if you add some other terms on or subtract them, like negative 2x squared and so on, nothing higher than x cubed though. You can distort the shape. You can cause it to look like this, which gives you actually 3 roots or 3x intercepts. It can cross at one point and then what I call bounce off another point. And it can also come through like this, where you only have one root and it bends backward but doesn't hit it again. So for a cubic equation or a cubic function, you can have 3 roots, 2 different roots, or just one root. Now, if you put a negative in front of the x cubed, it turns it upside down. So rather than coming through and going up like this, it starts high and ends low. And that goes for all the varieties of it too. If your leading term is negative x cubed, doesn't matter what else you put on the end, you will start high and end low on the right hand side. Again, you could have 3 roots or 1 root in what we call a double, or simply 1 root. A cubic must have at least 1 real root. One place where it crosses the x-axis. Now, if you're given the equation in factored form, it's very easy to draw the graph. For example, if you're given these factors, there are 3 numbers that will make the y 0. X could be negative 2, positive 1, or positive 3. So these are the 3 places that this graph will cross the x-axis. In this case over here, there are only 2 zeros, negative 2, and positive 1 is a double, and I'll look at what happens there in a minute. The first thing you have to decide is, on the right, I always work from the right hand side, so what I do is I come over here and say, okay, x times x times x is x cubed. So I'm going to end going upward. Another way of making that decision is pick a number bigger than 3. All of these factors will be positive, and a positive times a positive will give you a positive number here, which again supports the idea that you're ending going upward. So I start tracing it from the right hand side. I go down through the 3, back up through the 1, and then down through the negative 2. And I get a graph that looks like that. In this case, again, I start high because it is a positive x cubed if you were to multiply that out. But when I come down, because it's a double root, I don't cross at the 1, I bounce. I come off the 1, go up, and then cross at the negative 2. And it's going to look like that. You see, when you pass 1, this factor changes from positive to negative, but it doesn't result in a change in the value for y because it's squared. So that's what it looks like at what I call a double root. Here's another one in factored form, but you notice I put the x second this time. And what that means is if you multiply x times negative x times x, you will get a negative x cubed, which means this is what I call the upside down cubic. It's going to end going down. The other way of checking this is if you pick a number larger than 4, you will find that one of these factors, this one, is negative, which causes the y to have a negative value. So once again, start from the right hand side, go up through the 4, down through the 1, and back up through the negative 3. And that will give you a shape like this one. Now, finally, if you're given a function in this form, we have to use what's called the factor theorem. you take all the factors of 12. I've got them listed here. 1, 2, 3, 4, 5. Sorry, not 5. 1, 2, 3, 4, 6, and 12. And you have to check to see which of these numbers makes y equal to 0. Now, this is a long, laborious process, and when you're doing these, you usually start by checking the 1s and 2s and hope you find a 0 before you go too far along that list. What I found here was that x equal to 2 created a 0. And if x equal to 2 creates a 0 up here, then x minus 2 is a factor. X minus 2 is a factor. I have to divide x minus 2 into this, and I get this quadratic. Now, that's another story in itself. You have to be aware of how to do the division. The one thing you have to make sure of is that you get a 0 for the remainder. After all, this is guaranteed to be a factor. If 2 makes it 0, that is a factor, and when you do the division here, the remainder should be 0. And when you factor the quadratic, you get the other two zeros. And once again, the positive 2, negative 2, and negative 3 create the zeros. Because it's a positive x cubed, it ends going up on the right, so it makes it very easy to draw. You can tell from this equation up here that the y-intercept is negative 12. That's easy to see because when x is 0, y is negative 12, and that supports the fact that it has this particular shape. Now, one last thing. Sometimes these are easier to factor than going through the factor theorem. If you notice that you can take a common factor out of the first two and the last two, and you get the same in the brackets. See, in this case I got x plus 3. This is called factoring by grouping. Then I take the x plus 3 out as a factor, leaving x squared minus 4. And then I factor the x squared minus 4 into x plus 2, x minus 2. Same factors as up here. This doesn't always work, but you know, always look for that because it saves you from going through all of this. So that's how we graph cubics, and this is the standard cubic shape.